Hello students. My name is Vijay Sharma. I have done graduation in engineering branch electronics and telecommunication engineering. Today I will tell you something about P and N type semiconductor. P and N type semiconductor. This P and N type semiconductor plays a very important role in the field of engineering. Rather, we can say that in every field of our life. With the help of this P and N type semiconductor, we can make or fabricate diode, transistor, field effect transistor, SCR, flip-flops, resistors, and then integrated circuit ICs. I will tell you later on how we can fabricate these electronic devices with the help of P and N type semiconductor. And these all semiconductor devices, they are used in mobile, in washing machine, in baking oven, in TV, in laptop, in camera. We can say in the every field of life we are using this semiconductor devices. Okay, we will start now with P and N type semiconductor. So semiconductors are of two types: intrinsic semiconductor and extrinsic semiconductor. Intrinsic and extrinsic. So you remember like this, I for impure, but this intrinsic semiconductor is a pure semiconductor, or we can say that it is a natural semiconductor. Electrical conductivity of this intrinsic semiconductor is very poor. To explain this intrinsic semiconductor, we are having two types of semiconductor crystal: silicon and germanium. Silicon and germanium. The atomic number of silicon is 14 and germanium is 32. The outermost orbit of silicon and germanium contain 4 valence electrons. 4 valence electrons. Because with the help of formula 2n square, we can place number of electrons in first, second and third orbit like this: 2, 8 and 4. In 32, 2, 8, 18 and 4. So in this intrinsic semiconductor, when we add a pentavalent or trivalent impurities, then we get extrinsic semiconductor. How we will get it, I will explain to you. This extrinsic semiconductor has a very good electrical conductivity. The impurities, pentavalent impurities are those impurities which have 5 valence electrons. 5 electrons in the outermost orbit. Example: phosphorus, arsenic, antimony. Atomic number of phosphorus is 15. when we add pentavalent impurities in the intrinsic, or we can say pure or natural semiconductor, we will get a p-type semiconductor. How we will get? We know that intrinsic semiconductor silicon has atomic number 14. So its atomic structure is like this: silicon. It contains neutrons and protons in the nucleus. First orbit we have 2 electrons, second orbit we have 8 electrons, and third orbit we have 4 electrons. And when we add a pentavalent impurity, phosphorus, we must add impurity having atomic number similar, very near to germanium and silicon. So phosphorus 15 and silicon is 14, they are very close to each other. So when we will add phosphorus nucleus, so first orbit 2 electrons, second orbit 8 electrons, third orbit 5 electrons. 4 outermost electrons of silicon will form covalent bonding with the 4 electrons of phosphorus, and 1 electron is left behind. This electron is called free electron. This electron is called free electron and responsible for electrical conductivity. And it will constitute N-type semiconductor. And negative, it is not negative, but we say negative because electron is left behind. More doping we will add in the silicon crystal, more electrons will get, and these electrons will constitute N-type semiconductor. Similarly, when in silicon, we add trivalent impurity. Trivalent impurity are of aluminum, boron, indium. It is also gallium. Atomic number of aluminum is 13, which is very near to atomic number of silicon. So atomic structure of aluminum, nucleus. In nucleus we have neutrons and protons, and in the first orbit we have 2 electrons, second orbit we have 8 electrons, and third orbit we have 3 electrons. So when we add this impurity, trivalent impurity in this intrinsic semiconductor, 3 outermost electrons will form covalent bonding, and a vacant space is left in the aluminum. This vacant space will create hole and responsible for p-type semiconductor. When we add more doping of aluminum in silicon, we will get more holes and we will get a p-type semiconductor. This doping is very small. In the original crystal of silicon, if 10 raised to power 8 atoms of silicon, we add 1 atom of phosphorus or aluminum. By adding doping, by adding impurities in intrinsic semiconductor, electrical conductivity of intrinsic semiconductor increases 16 times. So this is something about P and N-type semiconductor. So with the help of this P and N type semiconductor, when we will join P and N type semiconductor, we will get a diode, and two diodes connected back to back, we will get a transistor. With the help of this transistor, we will fabricate gates, resistor, ICs, and these semiconductor devices are used in every field of every field of engineering, every field of medical, in every field of our life. So students, I invite you to my to my classes on YouTube, whose name is Vijay Kumar Sharma, and my mobile number is 977-958-2058. Okay, we will see again. We will meet again with the new topic. Thank you.